Recently, the National Oceanic and Atmospheric Administration's NOAA Space Weather Prediction Center issued a G4 geomagnetic storm alert. This was due to at least 7 coronal mass ejections, CMEs, from the Sun. These CMEs can trigger geomagnetic storms, solar storms, that reach Earth, resulting in issues such as radio interference and satellite disruptions. Solar storms are classified into 5 levels, from G1 to G5. Luckily, this solar storm concluded without causing significant damage, only creating some stunning auroras around the world. Today, we will delve into the principles and history of solar storms. Solar storms, auroras, and their impact on the ionosphere. Just as the Earth rotates, spins on its own, so does the Sun. Just as Earth has a magnetic field, a space with magnetic lines of force that have an attractive or repulsive force, there are magnetic lines of force around the Sun that create numerous magnetic fields. However, unlike the Earth, the Sun rotates at different speeds in different areas, causing these magnetic lines to twist and tangle. Where these lines are most twisted, the temperature is cooler, making these regions appear darker. These dark, heavily kinked areas are known as sunspots. Sunspots are areas of strong magnetic field activity that are cooler in temperature than their surroundings, but they instantaneously radiate energy outward. This is a solar storm that causes a space weather event called a coronal mass ejection, or flare. During an 11-year cycle, when sunspots become exceptionally bright or numerous, they have a significant impact on Earth. This is because high-energy particles, such as electrons and protons, are ejected from the Sun in the form of plasma, which then travels toward Earth. Coronal mass ejections, which contain high-energy particles, disrupt communications when they reach Earth, but also manifest as auroras at the poles. The years following peaks in sunspot activity, when sunspots are most active, are known to be the most frequent for the occurrence of the mysterious aurora borealis phenomenon. When high-energy particles from space collide with oxygen, O2, molecules over the polar regions, an electrical discharge phenomenon occurs, producing light. This twinkling, spectacular light display is known as the aurora borealis. Despite being typically seen only in the polar regions, the aurora borealis has been observed in unexpected locations such as the U.S. and Latin America, including Florida, Cuba, and Colombia, even causing disruptions to computers. The Carrington event, recognized as the worst solar storm in history, caused widespread effects. Since then, there has been extensive study of solar storms and high-energy particle activity, particularly as society's dependence on electricity and electronics has grown.